Okay, good morning. Today we are going to discuss about features extraction further. So before this, we have discussed about binary object features like Euler number, like thinness ratio. So today we are going to histogram features. So you click part 3. Okay, so histogram features means features that you extract from histogram. Like you want to calculate the mean, calculate the standard deviation or variance. All right, so there actually has close relationship of the characteristic of image lah, like brightness and contrast. Okay, so we look at the first example here. If you look at a bright image, so what happened to bright image? All their pixels values tend to be high or low. Bright image.
Hi, sir.
High. Okay, so when it is high, so you look at the histogram. This is histogram, right? So in this y-axis is the frequency, meaning that how many pixels that has that brightness. So the x-axis is actually the brightness lah. Here brightness 0. As you go towards the right, the brightness gets higher. So this is the histogram. So if it is a bright image, then what happened is you can see that most of the pixels will the bar will be shown in the high brightness level. Okay, if the image is dark, then you can see that the histogram tends to shift to the left lah. Most of the non-zero punya ni is actually in the dark image. Right. So so how do we differentiate between bright image and dark image? So we can actually calculate the mean. Right. So if it is the bright image, so if you calculate the mean, obviously the mean will be high. And if you calculate the mean for dark image, then the mean will be low. All right. Any questions so far?
No, sir.
Okay, great. Okay, next we talk about the contrast. So contrast actually has close relationship with the spread, okay, of the histogram. So if we say low contrast means the bright and the dark is very close to each other, so they are quite similar. So or in histogram you can see a clustered histogram. Clustered, okay, meaning it's very narrow, not well spread. Okay. Okay, on the other hand, if you go for high contrast image, then you will find that the histogram is very spread out. So what can we measure to know whether it is clustered or spread out histogram? So we can use the deviation, standard deviation, or you can calculate the variance. So the variance for this or the standard deviation is going to be low, and then this one, the standard deviation is going to be high. So that's how we can use variance or standard deviation to measure, to indicate the contrast of image. So high contrast, so the variance or standard deviation should be high. Same goes with low contrast. So your standard deviation and contrast is going to be low. And then we have this kind of histogram where you have this image in contrast with the background. So you can see that histogram has a bimodal shape. So why bimodal? You can see that, okay, each of the peak here actually means there are many pixels with this gray level. So if you look at this image, there are only two objects. The first one is the copter, which appears to be darker. So this is actually the second peak here. Sorry, the first peak, which is in the darker gray level. And then the background, the sky, which is bright, so and which forms the majority. So that's actually is the peak, second peak here, which is at the brighter level. So this is a bimodal. Bimodal means a histogram with two peaks. So for bimodal, then of course you can see that you have a good contrast. So the variance or standard deviation is very high. And then you also have a so-called a balanced histogram, and you have two peaks. So one way that you can measure the balance too, whether they are, you can calculate the skew. So the skew actually will measure how asymmetry. Skew means dia tahu skew kan, dia kecenderungan. So maksudnya dia tak balance lah. How unbalanced the distributions, dia cenderung ke arah mana, kiri ke kanan. Tapi in this case, bila kata bimodal, dia the bimodal means there should be two peaks which is balancing each other. So the skew should be high or low. When it is balanced means the skew should be very low. So means it is not unbalanced, it is balanced. So if you want to detect this kind of bimodal shape, so we have to measure first contrast must be high, second the skew must be low. So far, any question?
No, sir.
Okay, so for the sample questions, so I hope you all have access to the sample questions. So you could look at sample questions related to these topics, which is under features extraction, I think number 23 or 27. Oh, sorry, it's actually as 22. So by using histogram features such as mean, variance, mode, skew, how to differentiate bright image and dark image. So what you can do is you can use for bright image, what happened? You can use mean. So so bright image has a higher mean as compared to dark image. And how to differentiate good contrast from those of poor contrast? So you can use variance. So good contrast, you should have high variance. And then how do you identify image with object in good contrast with background? So they should have high variance, the bimodal, high variance, and low skew. Any questions so far? Okay, everything, this one?
Yes, sir.
Okay, next we are going to the, so you click part 4, and then you will come to classification. And before that, can mention a little bit more. So we have talked about binary object features, we'll talk about histogram features just now, and there are some other features like color features. So when the main things to differentiate the two groups objects is based on color, like skin tumor detection, face detection. So you can make use of color, but just want to highlight, when we do color features, usually we don't use absolute. Okay, avoid using absolute color measure like RGB. It's not robust, not flexible, because it include the lighting as well. So usually what we do is we use relative color measures like HSL, SCT, because all this you can see they have the L here. Okay, the L and SCT as well. They will separate out. Okay, one lighting component and also two color components. So you can reduce the dimension. Like RGB, you need to involve the three components, but in this color space, you can ignore the lighting and focus only the two dimension color components. So that will help you to reduce the dimension and easier to do the classification later. And also we have discussed about spectra features. Remember when we talk about this, how to differentiate different costs, different leaf with different texture. All right, so A is smooth, B is coarse, so we can actually look for their high frequency, which one has more high frequency. So we are usually when we talk about frequency, we are measuring their power. So how do we measure power? So we actually square the coefficient. Okay, so with that, then we can actually classify based on smoothness or coarseness. All right, and smoothness, coarseness is actually just as we say whether it's a higher kind of frequency, but there are actually more. You can see, you can actually define certain band of frequencies. Okay, certain band of frequencies. So this is just for your reference. Okay, today our focus will be on pattern classification. So when we say we take classification, means we take the features extract from image and then we try to classify the object automatically. All right. So usually we use distance or similarity measures. Okay. Which we have not discussed before. So maybe I can look into. Okay, never mind, I'll talk about it later. Okay, classification is something like this. I give a simple examples. Suppose you have three groups of object. Okay, let's assume these are the face features. Okay, which consists of two features lah. Okay, that's why we try to recognize face by using the roundness of face and also the color of face, for example. So consists of two features. So this is the face of Hadi, this face of Shafika, this one face of my face. So now when we say we do classification, means it's involved typically we have one unknown. So we have one input image that we want to recognize. This image belongs to who? This image belongs to which group? So by using a very simple logic, okay, in this case, I try to visualize this is a two-dimension feature space, and this is where the three groups are. So by looking at this yellow unknown, so logically this one should belongs to which group? The red group or the green group or this one or the blue group?
Blue ones.
Yes, logically we look for the group which has the nearest, which is nearest to the unknown, and we classify to the nearest. And if let's say this one appears to be here, then naturally you will say this one belongs to the red group. And if let's say it is here, then you will say, so you always look for the group which has the nearest distance. So then the next question is you nak kira macam mana dia punya distance. There are many ways to calculate distance lah. Okay, the one that you have learned in your secondary school, the Euclidean distance, where you take the difference in x and difference in y, kan? Remember? And then you square them and then you calculate the square root. Still remember that? Yeah, that's exactly what we're going to use later on. Okay, to use to classify the input to the groups that we already have. So you can imagine these are the samples that we have for our reference. This one katakan ini dia punya group for triangle, ini group for circle, ini group for square. So if you want to know whether this input belongs to which group, then we calculate their features and then we compute the distance of features to each group. Okay, so exactly how to do the comparison, actually there are various ways lah. One is we look for the nearest. Okay, we compare to all the samples here. There are 9 samples here, so you compare the 9 samples and you check which one gives the nearest. So in this case, the samples that is nearest is this one, and this one belongs to the blue group or the upper square group. So therefore, the input should also belongs to square. So that's the kind of logic. Another one is instead of comparing to all the samples, maybe we can calculate the mean of each group and then we just compare to the mean. So this one will have advantage where you don't have to compare with 9 objects, but instead you just compare with 3 means. That will reduce your computation and make it faster so that you can have a more real-time computation. All right. So all this actually is available here. Pattern classification. So we have the nearest neighborhood method. Okay, so the one that I explained, nearest means you always classify, compare to every sample, and then you look for the one that is most similar. All right. But performance sometimes affected by outliers. So imagine like, for example, you have one outlier, this one, okay, which is actually very much different from this group. So when you say which one is the nearest, then you find that this is the nearest. And then you say, oh, it belongs to the red group. Actually, you are comparing with a sample which is not so normal, or we call it outliers, abnormal samples. Okay, so that's why then we said, okay lah, we go with so-called voting kind of scheme. So we go for majority winner. So we go for some k nearest. So for example, we set for k is equal to, okay, let's say I give example nearest, in this case 3. So 3 then we'll assign to the close unknown to the class which most often set. So meaning that, okay, so instead of just 1, so we look for the nearest. So in this case, although this is nearest, but we still have the other 2 here, which is also nearest. So let's say we set to 3. So out of the 3 nearest, which one is the majority? The blue color, the square. So then we assign this to the square. So you can see that this k nearest is kind of democracy system. Instead of we rely on one single king, now we rely on a cabinet, or we rely on a group of leaders that form the cabinet, so that if let's say one person is corrupted, we still have the rest, to run the things correctly. So that's the reason why we have this neighborhood method. Any questions so far? Okay. Last but not least, for this, so the above 2 methods is very computational intensive because you have to compare to each sample. So usually you can see that like in face recognition, we may have like one, for one city, we may have 2-3 million users, and one user you need to take like 4 samples, 3 samples, then you're talking about tens of millions of samples. So if you were to calculate like this, then it will gonna take quite some time. So to speed up the thing, usually what we do is we try to compare to the mean of the group. All right, so this is called the centroid, nearest centroid. So you calculate the centroid or the mean for each group before you compare. So when you compare, instead of comparing to each samples, you only compare with the mean. Any questions?
No, sir.
Okay. So we'll look at one of the samples here. Okay, so this is the kind of questions that you get next week. Okay, so one is on the histogram features, like this. Yeah. The histogram features, the one that I've shown, histogram features. And then also one on binary object features. Okay, except maybe it's not Euler number, but thinness ratio or something else. Another one is the use of spectra features. And then another questions on features classification. So I'll give you 2 groups of object A and B, each with 2-dimension features. So, okay, how do you interpret Euclidean distance? What does it mean if the number is small or large? So when the distance is small means, are they similar or not similar?
Similar.
Yes, when the distance is small means the unknown and what you are comparing with is similar. Okay, when the distance is large, means they are not similar. Okay, so we'll give you one features vector in unknown. So this is the unknown. So you are asked to classify it by using nearest neighborhood method. So you need to calculate lah. How to calculate? So you calculate using near minus each features minus. So then you square them and then you add. Okay, like in this case here, x1 minus x2. So this x minus this x, and then the y of this minus the y, and then square, and then square root. So in this case, if you try to take 95 minus 55 square, and then 22 minus 77 square, then you should be able to get 68 lah. Can you try to calculate whether you get that? 95 minus 55. How much is that? 95 minus 55, 40. 40 square is 1006. 22, can you calculate and then you tell me whether you get? $95, 22. $95, 22. Another one, 55, 77. 55, 77. This one minus this. 40. Square them. And sum the two. Jumbo. And then square root. Okay, so 68. I hope everybody, any question on the calculation?
No, sir.
No, sir.
No. Okay, good. Okay, just to give you another example, kata-kata 57, 74. 57, 74. So you get 64.4. Betul? So if you compare to each of them, so these are the difference that you have to calculate and then you show. And then from there, you need to make conclusion by looking for the nearest. Which one is the nearest?
5.
Yes, image 5 has the smallest distance, so this is the nearest. So since 5 contains object Bn,
Yes.
then we will classify the image I contain B. Any question? Simple logic?
No, sir.
Okay, so next will be nearest centroid. Okay, nearest centroid means you need to calculate their average. Okay, so you need to calculate the average for A and B. So calculate average meaning you need to take the average of for object A. So dia punya average 55 campur 57, 54. This is for features 1, and then features 2 you have to average 77 plus 74 plus 75 divided by 3. Okay, so that's the average. Okay, let me there. 55 apa? 57 4 and 77 74 25. So you take the sum and then you divide by 3. This is what you get lah. The average 53, 55, 75. Any questions to calculate that? And you repeat the same thing for centroid B. And then you do the comparisons again by using the Euclidean distance. So instead of now you compare with each image, you compare with the centroid of A and centroid of B. So now if you take this 50 instead of ambil yang ini kan, so I ambil ni sama dengan ni. So you calculate dia punya ni 66.46 kan, 66.5. And then you do the same for B, so you get dia punya difference 2.1. So do you get the same result? Yes. Why? Because you classify to the nearest centroid, which is B lah. Okay tak?
Okay, sir.
Alright, so I think itu sajalah untuk yang test. Sekejap, saya nak macam mana nak stop recording.